Okay, welcome back. Okay, back to a little more science-based, although it's kind of interesting. I felt like watching the videos. I rewatched my last one already just to kind of get a feel for how it was in terms of offensiveness, maybe. I don't know. I was okay with it, honestly. It is what it is. It's gotta be blunt and honest. So anyway, I saw this shalogram. I thought I'd just kind of start with this open. It's interesting. I don't usually see them so triangular around like a point of the focal point like this. Who dat? Who dat? So this is cool. I wasn't gonna stop and talk about it really. I just kind of checking it out. Okay. Also, this I heard a bunch of earthquakes here. Bunch of earthquakes here. Earthquakes. San Andreas. Okay, maybe let's try Twitter. Let's see what Twitter's saying. Earthquake, just earthquakes with an S, because there was a swarm. Back to Turkey. Interesting. What's with all the earthquakes happening at once? That was on the 23rd, a week ago. Okay, nothing. I don't know where I happened upon it, but something said a bunch of earthquakes moving towards the San Andreas Fault, not at the San Andreas Fault, although that looks like it's at it. Bunch of them. The biggest one here, I think, was a 4.3. That's not tiny. I mean, it's not huge. Another 4.3. 3.4 is not huge or anything, but considering there's a swarm here, it's certainly of note. That's all. Noteworthy. That's maybe. I haven't looked at earthquakes recently. Let's check out the last 7 days. 4.5. I don't know why. .1 sorts by largest magnitude. 7.1 in Indonesia on the 24th and the 23rd over there. Fiji, 6.6. Just a bunch of stuff along here and there. Indonesia, South Sandwich Islands down here. In the Aleutian Islands, maybe? Is that the Aleutian Islands? No. What is that? Scotia? Scotia Arc? Yes. Scotia Arc. Okay. Some earthquakes down there, I guess. In the Mid-Indian Ridge. Another earthquake over there. The South Sandwich Island, Indonesia. Just mostly the big ones are in the same general locations. Fiji, Chile, Rise over here. Fiver. Okay, so I'm just checking that out. Okay, so let's close this. And now, the reason I hit record was because I wanted to actually go through these things. So I looked around for some, what I was looking for is recently in this video, I think it's this video, this video, he was saying basically, I think it's right here even.
So if you start eroding the Appalachians, you get a bunch of these zircons out. So the thing that's interesting, one, is that we're out here in western Arizona, and in the early Triassic, the sediment was largely dominated by grains that originated from the Appalachians. But then over here, there's a bunch of younger dates, like 300, 250, and we
Like right after the Permian extinction.
look at the youngest populations, and this tells us that this rock has to be younger than this age.
Like some major global processes were occurring at the Permian extinction that included transporting large quantities of grains of sedimentary deposits from the Appalachians to western Arizona and southeastern California, as well as where that's what I was like, well, this I saw recently my last night I saw Myron Cook had a new video about the Appalachian geology, and I posted a question. Well, I posted a comment where I just was like, pointed this out. I pointed this out. I said, and I recently saw this presentation by Steve Reynolds about the Western titled this, and at this time, and then I quoted, he says, "What's interesting is we're in the Western Arizona," and just straight quoted him, and asked Myron Cook, who's a geologist who makes excellent videos. God dang. And I asked him though, like, are there other places? And he said he didn't know of any. So I was like, what am I doing? I can just Google scholar search and just do it casually, like I did grains from Appalachians. At some point, I added Tasmania because I know there's some relationship between Arizona and Tasmania. Just out of curiosity, maybe if I say instead of maybe it may not be even related. Sediment grains Tasmania. Like it may not be known to be related to the Appalachians because obviously it's Tasmania, that's the Appalachians, but they were like closer. And I think they were literally closer more so around the time when possibly the Permian. And so it's possible that there's some sediments in Tasmania that relate to the Appalachians that aren't like tied to them in the most rigorous way because it just doesn't seem possible to plate tectonics models. So it's just like we don't know where those came from, kind of thing. Maybe where they don't even mention, like let's just say 1000 MA or something. Basin was in sandstones. From Proterozoic and early Paleozoic sandstones. Paleozoic is during the Earth's expansion. So it's possible that some of the grains relating to these Paleozoic sandstones, and possibly that too, are from the Appalachians, from the Grenville. Oh, Grenville. Oh my God. Boom. There it is. Tasmania, dudes. For people who don't know where Tasmania is, okay, here's the Appalachians. Here's Tasmania. How did they get there? But the thing is Tasmania used to be adjacent to Arizona. Like it's tied to Arizona. Maybe it was a wedge kind of in this location that got moved away to like open space. And it turned, and then Papua New Guinea reattached because it was further up here. and Tasmania was like down here, and then it physically turned Australia to face it this way, with Papua New Guinea reattaching, but then it deattached again, and maybe, yeah, looks like we just found this fun Grenville. Age profiles of these cannot be readily differentiated. Likewise, it includes samples with and without Grenville ages. Allowing this group doesn't seem to have Grenville. Contains an unusual profile dominant the Wings Sandstone of southern Tasmania. Contains an unusual profile dominated by Grenville ages, Grenvillian, which is the Appalachians before the Appalachians, the previous orogeny in that area, consistent with an lactonus of a depositor formation having originated at a distance from its present position. That's incredible. That's incredible. I didn't think I'd find something that easily. I gotta go like that. Wow. Which one was the wing sandstone? Let's just go straight to wing sandstone. Wing sandstone. Jubilee region. A massive, structureless, fine-grained quartzurite. Let's just see Grenville. Get out of the abstract. Okay, that's sorry. I know I can kind of read it, but it's probably tiny otherwise. Kind of read it. I need to freaking stop staring at computer screens before I go blind, honestly, it seems. Age of 1200. Thought to define an early regional Grenvillian age metamorphic event. The implied pre-Grenvillian depositional age has not been disproved by our detrital zircon results. Markedly different wing sandstone profile at first sight supports an allochthonous at a distance origin for this unit. However, this wing sandstone sample is not entirely dissimilar to the other Proterozoic samples because it has the widespread 1450 million population and at least two other younger data concentrations are similar in age to those seen in the Jacob quartzite. It may be that the wing sandstone simply represents a further development of the trend from the detention subgroup to the Jacob quartzite with further diminution of the older population and even greater predominance of the Grenvillian source. So I guess this one actually even went down to Tasmania practically. So that's a little more reasonable because Tasmania was very close to over here. This doesn't show Arizona though. This is almost assuredly all sediment deposits over here, down here. I would hypothesize at first glance that these are sedimentary from the Appalachian region, just because of the way this curves right there, which ties way too much into this curve here. It almost is like it's based on that curve and related to that curve in some way. And if it's related to this curve, that means it was deposited in the current flows that were shaping this curve. So it cannot be that it was just casually happened to be that shape. Like it would have not been like that. Presumably, I mean, it's literally coincidence if it was. It's too coincidental to be just simply taking at face value. Grenvillian source. Okay, let's keep moving. Mississippian sediment dispersal network originating in the Appalachian orogeny, traversing North America along its southern shelf and reaching as far as the southwest United States. Let's find a map. Figure 1, basement map of major North American geological provinces. Grenville orogeny is the dark purple, which again has that shape. Appalachian has that shape. Strongly suggestive it's related to the current in this region, especially having that shape. What do we got here? We got Oklahoma, Colorado, 0.5 billion, so 500 million, around the start of the expansion of the Earth, were this little string of things. And then older things, and then again Appalachians during Earth's expansion. Pan-African before Earth expansion, which apparently included the Yucatan Peninsula and Florida. Let's see, what do we got here? New and compiled detrital zircon age distributions plotted as pie diagrams on late Ordovician, middle Devonian, early Mississippian, and late Pennsylvanian paleogeographic maps from this place. From Brand et al. Paleo current trends, black arrows from Brand et al. Inferred Mississippian sediment dispersal pathway, shown in yellow on panel C. That's weird he doesn't bring it down this way and up this way, because it's definitely found over here. It's good though. Like, this is capturing some of this. Current coming across this way and down this way. How close is this, like, when it goes down? This central Texas, so it goes down a little earlier. Like, it goes down through the Mississippi and then over. So it's like there may not be any here. That would be, although actually it wouldn't be surprising, because if we actually look at this stuff that's going more so over this way is, no, there's gotta be some up here, because it's going over here, unless it goes down this way and goes up there kind of thing and doesn't go this way. But this follows way too closely. No, it doesn't even follow there. That other thing I saw, though. But notably, Colorado, going into Colorado and through it and across and then up through. So basically into, maybe generally this way, down this way. Maybe it does go down through here and wrap around. Go like that and get into this system, which then disperses it out through like the Grand Canyon kind of pathway up this way, possibly to the right of the resistance of all this, like put pressure this way, putting stuff more this way. I'm not sure if that fits there. But for certain, this is crazy. That's very informative. I was expecting to not actually find anyone talking about this because of the way this video sounded, where it sounded like surprising, truly surprising, to a point where like there's almost no discussion of like a countrywide process of these movements of Appalachian zircons, but apparently there is a map done, so that's cool. Let's go ahead and maybe go to conclusions. Documents a previously unrecognized Mississippian transcontinental sediment dispersal network that began in the growing Appalachian Mountains, traversed the southern margin of North America, and is recognized as far as the southwest U.S. fluvial deltaic processes played a minor role in the transport of the Appalachian-derived material westward. Instead, shallow marine processes, tide currents, and possibly hurricanes. Interesting. Likely hurricanes, like the Earth expansion process. I'm pretty sure the clouds and things aren't like, there's not like birds chirping and everything's happy. Like there's storms of that scope, probably like everywhere practically, to a point where there's like evidence enough where like they hypothesize it. Just a thought, I don't know. Likely transported sediment westward and parallel to the shelf is currently observed along the eastern margins of Australia and South America. Oh, freaking TV, just shooting all the time. Detrital zircon age distributions in Ordovician and to Devonian strata indicate that North America was partitioned into 3 first-order domains prior to establishment of the Mississippian. 3 first-order domains, like 1 domain, 2 domain, 3 domain? I mean, they said North America, but just extended further. It pretty much still does the same thing further north. Just where, like, this is a domain over here that's more like part of that one. And then the center portion is more like this region. And then this side is connected to this because the ammonite shapes here are kind of like a continuation through the whole continent of this 3-tier thing that they mentioned, maybe. Partition prior to Appalachian-derived detritus became more widespread in Pennsylvanian time as sea level dropped. Pennsylvanian eon period. So around 300 million. Fluvial and aeolian processes, water, like flood and wind-blown processes continue to disperse these materials. Okay, this one I was excited to read because it said Navajo sandstone. I was like, Appalachian. We got 13 finds on that word. Characteristic of the Grenville orogeny age crust involved in Appalachian orogenesis. Our findings require the existence of a transcontinental sediment dispersal system capable of moving a large volume of detritus westward throughout the late Paleozoic and early Paleozoic, late and early Mesozoic, so basically around 252, around the Permian extinction. Again, tying the Permian extinction to an actual process on Earth. Fluvial transport. They're showing it this way. Interesting. That's Figure 1, generalized geological map of North America showing uranium-lead bedrock ages and inferred early Jurassic sediment distribution pattern. I'm not sure what that is. Is that this thing? The dashed line one? It doesn't actually indicate where, I guess the fluvial transport. Base map is after Hoffman. Locations of anorogenic granites are after Anderson. Represented here, blah, blah, blah. Approximate bounds of Navajo, Nugget, Aztec, Erg, shown in pale yellow. Aeolian transport. So this is around the Colorado Plateau. Of sediment to Navajo, Nugget, Aztec, Erg are shown schematically. Okay. Discussion. Conclusions. We have developed a technique for measuring both crystallization and cooling ages of single zircon crystals. Blah, 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 blah. Application of this technique to the Jurassic Navajo sandstone demonstrates that the bulk of the material in the Navajo sandstone was ultimately derived from the Appalachians. I didn't expect all these to be fucking home runs, dude. Home runs. It's not like, oh, we found some zircons. They're like, all these zircons? All of them from over there? And there must have been some river system, as we've determined. They came from over there somehow, so they must have got transported over here. What? Oh, we found some more. Shed from the Appalachian into the Grand Canyon. So Arizona again. We're finding again. Permian strata contain abundant Appalachian zircons. Permian, probably in that time frame. Oh, 270 meaning ones that were in the Appalachians at 270, but by like 252 they were on the move across the country because shit was hitting the fan in the first step of the Earth expansion. Not the first, one of the more major steps, I guess. It's not the first of the extinctions or the last, but it's a major step in the process. Is the 252 million year time frame. Compilation of young ages from all Paleozoic strata yields ages just before. Okay, so another one, Grand Canyon. So we got Grand Canyon, we got Arizona, we got Colorado Plateau, we got Tasmania. This is another Colorado Plateau, another Jurassic Aeolian associated sandstones. Let's go ahead and just Appalachian. The most prominent peaks of the constituent age populations reflect a derivation from within the Appalachian origin or sedimentary cover. So from the Appalachians. So that's just another Colorado Plateau one. Kansas, northwestern Arkansas, southwestern Kansas, northwestern Arkansas. Let's see. Appalachian 53 times. This study explores the influence of the Allegonian Ouachita Marathon orogeny and ancestral Rocky Mountains uplifts on sediment dispersal in the Carboniferous through sandstone compositions and detrital zircon provenance analysis. We focus on upper Mississippian to middle Pennsylvanian siliciclastic intervals in two areas. Okay. This place, southwestern Kansas, and this place, northwestern Arkansas, where samples were collected from Pennsylvanian outcrops. We report these things characterized by major, I don't know why it keeps doing that, major Grenville, oh, it's this text in the background, major Grenville and Taconic Acadian age clusters. Okay, that's suggesting a persistent source in the Appalachians tied to the Allegonian orogeny. Let's just scroll and see what kind of pictures we got here. Pink. Does it list the color name? What? It doesn't even describe the colors explicitly. This color, at least. Grand Canyon. Not that. Okay, let's go to conclusions, maybe. Just check these out real quick. Whatever. Equator. So the mantle puncture hole is here, and then it goes to what I've since the beginning been kind of suggesting to be the equator at the time. It goes this way, goes this way, goes this way, and then interestingly it comes across this way. Generally speaking, like it goes across directly into North America and just continues maybe at this angle right here, maybe that angle, but generally across at following this. This looks pretty much like it closes up more like this, so it can almost just continue across like as if the ocean wasn't there, just doop. So it probably does go right here. So let's see again, where was that equator? I mean, we can see, I guess that's California, and that's Idaho. No, there's Nevada, Arizona, South Arizona, New Mexico. I mean, pretty close. Maybe actually here we can see it. Maybe. Just in general, the way it is here. Maybe it continued right through this region. It just kind of went across until it ran into resistance. To a degree, until at some point it built up so much pressure here in the Omega wall that it started to go around it, and then it flowed this way, which is probably around I think this is around the KT boundary when it gets over here, though. So, like, it's flowing this way. Maybe around when it gets here is around the Permian extinction time frame. I don't know. Just given the data that where we keep running into Permian time frame for a lot of stuff. Okay, conclusions. Up. Correspond to dominant source in the Appalachian region. Upper Mississippian samples in southwestern Kansas. Right, southwest. Didn't they say northwestern Nebraska? South. I thought they were like adjacent like this. Southwestern Kansas, northwestern Arkansas. I thought it was Nebraska. Oh, that's why. It is adjacent. Northwestern. Oh, no, it's not adjacent. Northwestern, southwestern. This is very near the center. This region, maybe even in this region specifically. I'm not sure where they're finding these. Maybe we can look at the map they have. Consistent with a persistent major source in the Appalachians for much of the Carboniferous period. So, leading into the Permian extinction. New and published data from across the Range confirm that in the late Mississippian, deformation along the eastern margin of the Laurentian tied to the eastern margin where this current is moving like out of the resistance, so probably pushing a lot of material underneath it until it can like get around and carve an actual separation between North America, Europe, and Africa. Delivering sediment with a relatively uniform and strong Appalachian signature as far west as the Grand Canyon in Arizona and Tasmania. Although shelf continued to receive Appalachian source sediments, transcontinental sediment distribution systems further west were more complicated and were dominated by erosion and recycling of these basement uplifts, which kind of makes sense because that's where this current's coming in and interacting. So like the Appalachians are dominating the flows this way, but over here they start to mix to a point where they're not dominating the flows and they become present but not so like exclusive, where this is persistent major source. Where did it say it? Dominant source. Okay. Evidence for multiple recycling in Neoproterozoic through Pennsylvanian sedimentary rocks of the Central Appalachian Basin. I don't know if this was actually elsewhere. Doesn't look like it. Let's just move on. Late Miocene fluvial sediment transport from the southern Appalachian Mountains to southern Florida. So that's another place. Mind you, that's another place that I drew here. Like connecting the currents to over here. So that's cool. I don't know where exactly in the southern Florida. Onto a stable carbonate platform in southern Florida. Late Miocene, which is pretty recent. Yeah, so like 5 million. That's pretty recent. unusual in that they are significantly coarser than marine transported sands in southern Florida, with discoidal quartz and quartzite class up to 40 millimeters in diameter locally present and have relatively high potassium feldspar contents. Tethys Seaway passed along the southern margin of the Florida basement. Was this right here? Like, did this become the Tethys Sea? This flow? And then, like, this flow? Like, ripping open the earth along the equator-ish of the time, maybe, which this almost certainly was. And this probably was too. It just looks weird because of the larger globe. So maybe it literally carved it to then continue this way to ultimately to Florida in the time frame they're talking about. Florida platform, shallow carbonate sea. I don't really want to look too closely at this unless something immediately pops out. Collier County. Maybe. Yo, we up in my hood? Shoot. That's southern Florida for sure. What are we looking at here? I'm not sure what these numbers are. A isopatch, isopac map, cumulative thickness of upper Miocene and lower Pliocene coarse greater than 1 millimeter, siliclastic, siliciclastic. Oh my God, sand-bearing strata in southern Florida. Southern Florida. So they're talking southern Florida. All the way down to the tip. Oh. Inferred course of the Great Floridian River. You mean right through. What was this called? Wales Ridge or something? Lake Wales Ridge, yeah. This anomaly of a straight line down the middle of the state. You mean that way? Possibly this way, over to it, and then down that way. And then generally just bringing material down here, and it looks like getting trapped in the Keys kind of area. Possibly with a eddy here happening. It looks like there's an eddy here. Where half of it is here and the other half is like the negative, positive, negative, positive. Yin yang. There's a yin yang here. Maybe even continues and swirls in here. It's like the end of an ammonite, I don't know. Or here. Like the swirl around and then it there. It swirls out from here somewhere. And then to there. Maybe. So we got some more Appalachian stuff there. Mississippi embayments this Maastrichtian. I found just as soon as it said Maastrichtian, I just clicked it. I wasn't even thinking, because that's the KT boundary pretty much, right before it. Anything that says Maastrichtian, relevant. Anything going on in this time frame, very important with the KT boundary. It's just right before it. Basically the precursor steps. It's kind of like a pregnancy where like the birth pangs are happening, and then the KT boundary is like giving birth. The actual birth happens. And leading into it, there are some convulsions and things that are just more pronounced. Okay. I don't know why Appalachian derived grains contain 91%. Where are we looking at here? To support age for the establishment of the present day Mississippi River drainage system. So sands from the Mississippi River drainage system are 91% Appalachian derived grains. I guess this way. Oh, is it this whole width? It looks like it, honestly. Cretaceous, Quaternary. I don't know what to make of this, except just note it. So there's just more Appalachian stuff. Appalachian-derived sediments, Colorado again. We don't even need to look at this at this point. I mean, it would probably be beneficial too, but Mississippian age stratigraphic, Pennsylvanian, Permian, presumably all Appalachian. No, let's see. Locations of Appalachian-derived populations. So Arizona there, Utah, Colorado, Wyoming, Idaho. So it really did get all the way up in there. That's incredible. Oh my god, that's incredible. Okay, let's see. This study presents zircon age data from late Paleozoic sandstone units to track it's interesting there's sandstone too. Appearance of Paleozoic age zircons and sedimentary strata across the Colorado ancestral Rocky Mountain region. We also compare our data with published detrital zircon data from older and younger strata in the area to interpret change in provenance across Pennsylvania and Permian sandstone units in arm-flanking sedimentary basins. I don't know what that means exactly. Okay, probably some type of sedimentary basins. That has an acronym that they defined at some point. Were delivered to their final locations by interaction of several independent dispersal processes. No, independent. That include it's like a hurricane that like brings wind, like they're together, and rain, and like other things, probably even low pressure, all sorts of things that or high pressure. I don't even know. What the hell's wrong with you? You don't know, bro. I mean, it's in the summer. It's probably high pressure. It's gotta be high pressure. Also huge. Constructing source to sink systems from detrital zircon core and rim ages. Things like that where I just don't remember, it's kind of like biology. Like, you want me to remember the parts of the cell, mitochondria, what that does? I don't know. Generally speaking, I know it exists and is something relevant. Like, is that the powerhouse of the cell? Maybe. In terms of what that means, even if that's correct, I don't know. Like that kind of thing. Yeah, sometimes I don't know what I'm even thinking. Happens. Okay, Grenville zircons represent one of the most ubiquitous detrital zircon age modes on Earth. I guess because it's like the only thing that was really the source of that kind of zircons. Given the widespread occurrence of Grenville basement, Grenville detrital zircons are commonly viewed as non-diagnostic with regard to source region and provenance studies. Because it was just so big that it must not have come far. I don't know. Analysis demonstrates, though, that the Grenville detrital zircons exhibit distinct rim ages in different parts of the North American Paleozoic Appalachian foreland, whereas Grenville detrital zircon grains in the eastern foreland sourced from the southern Appalachian orogeny in the eastern United States exhibit these rims. These rims, grains in the western foreland derived from Mexico, mainly show these rims. This difference permits differentiation of non-diagnostic core ages by their distinctive rim ages. Nice, good to know. Let's go back to Tasmania, huh? Is this Tasmania? I think it's this one, yeah. Snow 750 zircon. I don't know if they say rim. Rim. It's probably just all shrimp and similar words. They probably don't mention zircon rims. Although they do have 750. It's possible the Tasmanian ones are from further west, like New Mexico, like I was saying. I think it said New Mexico, not Mexico, right? From Mexico. It's possible they're from Mexico because of this. Where maybe there would be cranes exhibiting that range more in this paper. I don't at a glance see anything that young, like intermixed in the conversation of what I was reading. I don't think. Wing sandstone. Leaving aside the wing sandstone. Oh, there's something. Ages of these. Subtle difference from them. Unmixing models predicts that more likely to be composed of 4 rather than 3 constituent populations. Ages. What are we reading? Probably similar. I just need any part of it that's talking about Grenville. Oh, that map maybe was. Maybe this map. No, nothing. Not looking like anything. Okay, let's carry on. Arizona again. Arizona. There's introduction. Okay, Arizona again, Idaho again, Wyoming again. We ran into those just on that map. Just casually glance through here real quick. Appalachian. Weber sandstone to determine if sandstone representing eastern and sandstone reworked within shallow marine and aeolian environments from the Wyoming Craton westward to the Pioneer Thrust Plate of south central Idaho. So basically, south central Idaho, like here. So it's like getting into this region maybe and meeting resistance enough where it just kind of stops in this region, but is still getting across like this way and maybe going up through here somehow, just through the resistance by just pressures to exchange, maybe heat exchange. Okay, that one only mentions Appalachians there. Okay, Granville orogeny there. Granville, let's say Appalachian. Doesn't say Appalachian. But this one says Antarctica. Many paleogeographic reconstructions of Rodinia link exposures of the Granville orogeny in southern Laurentia to late Mesoproterozoic orogenies in central Australia or in the Transantarctic Mountains of East Antarctica. Extensive sedimentation in the interior of the continent. Okay, so this one doesn't like say Appalachian so much. And we're done. Alright, see you guys next one. Peace.